mix in is called base drawing. We'll define a new object, robot drawing, because we're going to include the robot. We'll mix in base drawing. It will contain some objects of type base view. Those are the individual views that we see inside the drawing. The drawing itself represents a sheet of paper. So the first view, we will call it a tri-view, and that will be a trimetric. Its type, of course, is base view. The projection vector comes from the list of standard views. In this list of standard views, we can evaluate here at the top level. Standard views, you can see, contains a top, bottom, left, right, etc. And one of those is trimetric. We'll have to change that :tri to a trimetric. Now the objects themselves, well, we'll call them the object roots. This means the leaves from whatever we specify in the list will show up in the drawing. So we're going to list the robot assembly. We will need an object in our tree called robot assembly in order to be able to pass it in as one of the object roots. So we'll establish a hidden object. We'll call it robot assembly, and its type will be robot:assembly. This is a built-in example object in GDL, so we don't have to worry about compiling and loading this separately. Next, we'll make an outline for a top view, and then let's say a front view. Now let's fix this to say trimetric first, because that's the actual name. The top view will take the top. In the front view, we'll get the front from the list of standard views. So we see the three views, but we do not view those individually. For a drawing, the only way that it makes sense to view a drawing is to do an add node on the entire drawing itself. So we'll choose add node and we'll add the drawing. Furthermore, we have to use the PNG format because the SVG format does not yet support drawing. And the last thing, you want to make sure to choose the top from the view menu. And we just had to extend our window a little bit to see the top menu. But now we're seeing the drawing. And notice that right now all the views are on top of each other. That's because we have not specified them to take up less length or width or specified their position. So the first thing we'll do is give the tri-view's length will be half of the entire drawing's length, so half the length. And we'll do the same thing for the top view and the front view. So each one takes up half the length. Now keep in mind, the length is what you would think of as the height of the paper. The paper is laying flat on a tabletop, so the length is from front to rear, or what you would think of as the bottom of the page to the top. Now the center is the center of the view with respect to the center of the piece of paper, the drawing. So we'll translate the center of the drawing towards the rear, and again, that's what you would think of toward the top of the paper, half the child length. And likewise, for the top view and the front view, we'll translate to the front, half the child length. So that's translating the view again on the piece of paper representing the drawing. Now if we update, we'll see that the view at the rear, or the trimetric view, looks okay. Another thing we can do is add a border box to each of these. That makes it easier to see exactly where each view is positioned and what its length and width is. So now we see a border box around both of these. And we see that the front and the top views are still on top of each other. So let's adjust their width. Their width should be half the width of the entire drawing, and the same thing for the front view. And the center should be translated not only to the front, but also to the left for the top view. We'll take half the child width. And similarly, the front view we should translate to the right, half the child width. So let's compile that, and now we have the separated views as you would expect. Next, we can start adding some dimensions to the drawing, and we will leave that for the next video.